Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engines class. This is the chapter 11, this is the episode number 3, and today we are going to talk about the fresh water system cooling system. This is the heat exchanger cooling system or closed cooling system. Okay, my friends, right now we are going to understand what happened with the path of the coolant and the path of the salt water in the majority of the inboard diesel engines. Okay, in the previous episode we explained that there are engines that the refrigeration, the cooling system is with the circulation of salt water, and I recommend try to avoid that system because that system produces a lot of corrosion in the walls of the cavities where the salt water is moving, and produce too much accumulation of calcium in the walls of those cavities. And if the water is not moving constantly, the accumulation of calcium clogged those cavities and with catastrophic consequence. I don't recommend that system. That system is less used every day, especially if the block is in a ferrous alloy, steel or cast iron, ferrous alloy. Yeah, because the ferrous alloys are propense to excessive corrosion. Okay, today we are going to talk about the heat exchanger cooling system. This is better because we have a circulation of coolant, no salt water, internally in between the block and the head. We are going to circulate coolant, and the coolant goes outside in one element. That coolant reduce the temperature and return into the block with low temperature. In your car, that external element is the radiator. In your boat, that external element is the heat exchanger. That's the difference. Yes, my friends, this is the picture. This is exactly the picture. In these pictures, this is the automotive situation. This is the automotive situation. And this is the marine situation. Yeah, we are going to replace this radiator for this heat exchanger. And this is the procedure. This is one of the steps to convert the automotive engine into marine. This is the most important. Yes, my friend, right now we don't need the radiator. I want to use a radiator. Okay, it's possible, but you have inside of the engine room enough amount of circulation of air. No, the engine room in my boat is pretty close. That's not good. The radiator is not enough. You need good circulation of air in order to use a radiator. For that reason, in marine application with enclosed engine rooms, instead of the radiators, the engineers design the heat exchangers in order to decrease the temperature of the coolant inside of this pipe. The name of this pipe is the heat exchanger. Yes, my friend, it's pretty simple. Look at this. This is the automotive engine. The coolant, we are going to follow the path of the coolant. Look at the coolant. The coolant enter here because here is located the coolant pump, like the coolant pump that we have on the screen right now. This is a coolant pump with a metallic impeller. That coolant pump is bolted on the block of the engine. It's part of the engine. Different like the raw water pump. You remember in the previous episode the raw water pump? Normally the raw water pump is considered a separated element. In some diesel engines, the raw water pump is driven by a gear, and the gear engaged with the gear of the crankshaft and camshaft. But this is considered an external element. All right. In other engines, the raw water pump is driven by the belt connected with the crankshaft. You remember that? Okay. This is the situation. We have the coolant pump or freshwater pump or circulating pump here. Okay, that pump suction the coolant from the bottom of the radiator and circulate the coolant inside of the block and the head, inside of the block and the head, and return, and here we have the thermostat. If the thermostat is open, the coolant continue and enter in the radiator and return into the engine. If the thermostat is closed, the coolant stay a little more time in the block and the head until the temperature is okay, and open again, and the coolant circulate. What is the limit of that point? Is the boiling point, and we are going to talk later about that. Okay, but this is the path of circulation of the coolant. And what happened here in this radiator? What happened here in this radiator? This fan suction the air, and the air pass through the radiator and reduce the temperature of the coolant. This is the function of the radiator. The radiator have the cap over there. This is exactly the radiator that you have on the screen right now. This is in your car. This is the situation. Okay, and once again, the coolant enter in the bottom, circulate through the block and the head, and return. If the thermostat is open, pass over there and continue. This is the situation that you have in your car. It's pretty simple. Okay, in your boat, I am going to replace the radiator for the heat exchanger, and once again, the circulation of the coolant enter over there, circulate through the serpentine internally that I am going to explain right now, and return into the block. If the thermostat is open, enter, circulate to the block and the head, and return. What is this element? This is other option, and you send the coolant over there. The coolant enter in other serpentine and return. The serpentine is surrounded for fresh water. This is a freshwater tank for hot water on the shower. Yeah, this is very common for sailboats and small and medium boats. They use the coolant, exactly the same water heater that you have in your home. The water heater that you have in your home is with a resistor internally of the tank, and in this case, you replace the resistor, electrical resistor, for a resistor with coolant inside. Yeah, and you keep the water on the tank hot, and you can take a shower with hot water. All right. This is an element that we are going to explain in the course of auxiliary system. Okay, my friends. But the secret is replace for this element the heat exchanger. And today we are going to disassemble one heat exchanger, and we are going to check what happened internally. Okay, this is the situation. We are going to replace the radiator for a heat exchanger, and I can convert the automotive engine into marine. It's not complicated. Of course, there are other considerations about the motor mounts and about the fuel injection pump, reduce the wide open throttle RPMs, but the engine is the same. It's three simple considerations, and you convert the engine. The exhaust manifold is very important. Okay, in this video, I am going to show to you other explanation similar to the explanation that I gave to you right now. This is another explanation in front of my car. All the automotive radiators, they have one input and one output. This is the input. This is the input of the coolant coming from the thermostat housing. This is the input, and this is the output in the bottom. In the bottom is located the output. That hose return into the radiator. All the radiators, like the radiator that I have on the screen, they have one input and one output on top and bottom. From those hoses, the coolant is circulating. If I want to convert the automotive engine into a marine engine, I am going to introduce in the heat exchanger. This is the heat exchanger. The coolant here, the coolant circulates through the serpentine internally, and the coolant goes out. And the salt water coming from the sea enter over there and goes out. The salt water goes over there, and here both hoses of coolant enter, one here and the other one over there. In other words, I am going to replace the radiator for the heat exchanger, coolant and salt water. Right now, we don't need the air to refrigerate the radiator because the salt water right now refrigerates the coolant. Okay, my friends, and now I am going to explain again in this picture. This is the picture, this is the cover, the cover that you have in your diesel book. In this picture I have the typical diesel engine with a closed cooling system or heat exchanger system. We are going to follow the path of the salt water and we are going to follow the path of the coolant. Alright? Okay, the salt water enter in the button on the C-cock. The salt water enter in the button on the C-cock. The salt water, if the valve is open, and the salt water continue pass to the strainer. Okay, this is the strainer, and the raw water continue. This is the raw water pump. The raw water pump that is connected with the belt, connected with the crankshaft. And right now the salt water continue and enter here into the heat exchanger. And the salt water pass through the pipes directly in the other side, and the salt water goes out into the elbow of the turbocharger, in the hot side of the turbocharger. Yeah, like this video that you have in this moment on the screen. Exactly, the salt water pass to the hose and goes into the elbow. Okay, look at this. If the engine is located over the water line, that hose goes directly into the elbow and goes out into the exhaust pipe. But if the engine is located below the water line, you need interrupt that hose and install an anti-siphon, normally 12 inches over the water line or more if it's possible. Exactly, in that point is located the anti-siphon. Is located the anti-siphon to avoid ingestion of salt water in the combustion chamber during the cranking, not when the engine is running. Okay, my friends, and this is the circulation of salt water. And let me check the circulation of coolant. The coolant, this is the reservoir where you added the coolant, and this is other metallic reservoir or expansion tank, and you have the radiator cap here. Okay, and now the coolant circulate internally, and look at this. This is the path of the coolant. The coolant, this is the block. The coolant goes here, and circulate through the serpentine, and return over there, return over there, return over there, return over there, and the coolant enter only if the thermostat is open. And this is the coolant pump or circulating pump. If the thermostat is open, the coolant enters, circulate through the block and the head again, circulate through the block and the head, and return over there, and continue the circulation, and continue the circulation, and continue the circulation. This is the situation. The coolant never touched the salt water. The coolant never touched the salt water because the salt water passed through the pipes, like the pipe that you have on the screen right now, and the coolant passed around the pipes. What happened if I have a crack on the heat exchanger, in the heat exchanger that you have on the screen? If you have a crack on the heat exchanger, yes, you have salt water mixed with the coolant. And probably when the engine is running, if you check outside of the boat, you see coolant going out. For that reason, you need periodically added coolant into the reservoir. Yeah, normally this is the situation. The coolant is going out and mixed with the salt water and goes to the exhaust pipe. Yes, because if this element is cracked, you have mixture of coolant with salt water here, and the coolant goes out here, enter in the elbow, and in the exhaust pipe, you have salt water mixed with the smoke and a little coolant. For that reason, you need added coolant periodically on the heat exchanger. And also, when the engine is off, when the engine is running, it's normal that the coolant goes out. But if the engine is off and the heat exchanger is cracked internally, what happens? If the engine is off and the heat exchanger is cracked, the coolant in the engine is mixed with salt water. Then when you check the reservoir, the color of the coolant is not green, is not orange like originally. The color of the reservoir right now is brown because the coolant is mixed with salt water. If you remove the cap, if you remove the cap of the reservoir or the cap of the expansion tank, you found that a lot of calcium in the gasket of the radiator cap or in the gasket of the reservoir tank. This is an indication that the coolant is mixed with salt water. If you take a sample of the coolant and you send the sample to the laboratory, you found that a lot of, what is the composition of the salt water? The main components of salt water? Salt, sodium, and chlorine. You found that a lot of chlorine and sodium in the sample of coolant. And this is an indication that the heat exchanger is broken. What is the recommendation? Send the heat exchanger to a special shop dedicated to check radiators and heat exchangers, and they pressurize the heat exchanger and they verify if the heat exchanger is cracked internally. This is the technique. The technique used to verify if the heat exchanger is broken internally. Okay, my friends. Now I am going to show to you what is the path of the salt water in a typical marine engine with 5 or 6 heat exchangers. We are going to study in this small video how many heat exchangers are in a typical inboard diesel engine. Okay, let me start to explain the situation in this particular video. This is a heat exchanger with 2 compartments or 3 or 4 depending. The first one, input, serpentine, and output. The first compartment, input, serpentine, and output. The second one, input, output, salt water enter over there and continue over there. And the salt water reduce the temperature for 2 fluids. In this engine, this is the salt water. This is a tank that I put on that engine to simulate the salt water, to simulate the ocean. All right, that's the water. And this is the water enter here. Normally in this point you have the C-cock valve. Okay, after the C-cock valve, the salt water pass, the C-cock valve, pass to the strainer, continue the salt water, and the salt water enter into the raw water pump. This is the raw water pump, and here you have the impeller for the raw water pump. You remember that the impeller over there, that the raw water pump in this particular example is driving by a belt connected with the crankshaft of the engine. All right, that's the raw water pump with external belt. Okay, that's the raw water pump. The salt water continue and enter in the first compartment of the heat exchanger. The first compartment have 2. Exactly, that's the first one for motor oil. This is the oil of the engine for the first compartment. The second one is for fuel. Those are the fuel filter, that's the priming. Fuel filter, the second compartment. The third compartment is free in this moment. Why? Because in this moment I don't have transmission. Okay, when I connect the transmission, normally those hoses are connected with the transmission. In this moment is free. All right? Okay, the salt water continue, the salt water enter in other heat exchanger. Look, and return over there. What is the name of that heat exchanger? Look, salt water enter over there, turn here, and continue over there, and reduce the temperature of this. What is internally of this element? You have air. This is the air coming from the turbo. The fresh air, full compressed, coming from the turbo, enter over there. And the idea is reduce the temperature of that air in order to avoid vapor lock. Correct. What is the name of this element? The name of this element is intercooler or aftercooler. Alright, that's the intercooler or aftercooler. Okay, the temperature of the air is reduced because the salt water passes over. Of course, the salt water don't touch the air, because the salt water passes in a pipe and goes out, and the hot air is surrounded those pipes, and the temperature of the air decreases. Ay, papi, what happens if you have a crack internally in this element, in the intercooler or aftercooler when the engine is running? You have air entering in the combustion chamber with salt water, and you destroy the engine. Yes, my friend, right now you have two possibilities for intrusion of salt water in the combustion chamber, and we are going to refresh those two possibilities later. One possibility is during the cranking, if one of the exhaust valves is not properly calibrated, the last valve calibration, and during the cranking, in the elbow of the exhaust, you have gases with salt water. If during the cranking, a couple of exhaust valves don't close properly, when the piston is going down, the exhaust valve stays open and suctions salt water. This is the first possibility. The second one is here, in the intercooler. When the engine is running, if the intercooler, the pipes for the salt water are cracked, a little amount of salt water is leaking internally in the intercooler, and the air at high pressure enter in the combustion chamber with salt water, and the piston expand and bye-bye. Alright? That's the intercooler or aftercooler. We are going to talk later about that element in the chapter dedicated to turbochargers and superchargers. Okay, the salt water pass over there to the intercooler and continue over there. And what happened after that? Yeah, the air, the temperature is reduced before entering to the combustion chamber. That the intercooler and the salt water continue the salt water and enter in other heat exchanger. That's the heat exchanger for coolant. Look at the coolant, the radiator cap, and the salt water continue over there, enter in the elbow of the exhaust. Yeah, this is the hot side of the turbo. This is the hot side of the turbo. Yeah, the hot side. Alright. This is the hot side. You see Mr. Lopez showing the hot side? That's the hot side, where the smoke enter and spin the turbine. The excess of smoke goes out through this pipe and is mixed with the salt water entering here. In this point, I have salt water with gases. This is the point that I said that during the cranking, if the exhaust valve stays open when the piston is going down, suction that salt water. And finito. That's the point. Okay, and right now, in this point, the gases are mixed with the water. This is water, that's the point, that's the limit point, and this is water mixed with gases. My friend, this limit that I mark here is the limit that you need to take in consideration when you install an engine inside of the engine room. I am going to install a new engine, a new generator. This is the limit, the elbow on the exhaust, that you need to take in consideration in order to consider that the engine will be located below the water line or over the water line. This is the limit. Yes, you need mark internally in the engine room where is located the mark for the water line. And according with this mark, you say, okay, my engine will be located below the water line. Or over the water line. If the engine will be located below the water line, this hose should be going up over the water line 12 inches and return down. And we are going to install over there an anti-siphon. Okay, my friends? Very, very, very important. The anti-siphon, I am going to interrupt this hose, and I am going to send this hose up 12 inches over the water line and return here. Here, that's the point where I am going to install the anti-siphon. Look, I am going to interrupt this line, and I am going to send the line up 12 inches and return here. That's the anti-siphon required to avoid that during the cranking I suction salt water. Very important. Where is located? Is the hose that is going from the last heat exchanger before enter in the elbow of the exhaust. That hose goes up. I install the anti-siphon, and I return over there. Finito. That's the point. Okay, my friends? Okay. And now the salt water is mixed with the smoke and goes out. I am going to repeat this procedure in order to verify how many heat exchangers I have in total. That's the coolant. The coolant is located over there, and this is the expansion tank. And this is the heat exchanger. The salt water return over there, goes over there, enter, return, mix it with the gases, and bye-bye. Okay, I'm going to repeat the procedure quickly, my friends. Once again, I have the salt water, okay, the strainer, the C-cock valve, pam, 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 continue, raw water pump, that's the raw water pump, the salt water continue, first compartment for motor oil, second compartment for fuel, third compartment for transmission oil, the salt water continue, intercooler, reduce the temperature of the air, correct, before the air enter in the combustion chamber, continue, this is the number 4, and this is the number 5, salt water goes, and the salt water goes with the smoke, and bye-bye. This 5 heat exchanger. This one is for coolant. This is the radiator cap, this is the expansion tank, and this is the heat exchanger. Right now we are going to disassembly a heat exchanger, and we are going to verify what happened internally in the heat exchanger in order to understand that specific case. Yeah, right now we are going to check, we are going to verify this picture. This picture that I prepared for yours, this is a typical diesel engine. Look, this is the transmission, this is the bell housing, this is the engine, this is the fuel injection pump, those are the injectors, and we are going to check the path of the salt water, and we are going to verify how many heat exchangers are in a typical diesel engine, inboard engine. Okay, this is the salt water coming from the C-cock, salt water enter here, and this is the first heat exchanger. The heat exchanger for fuel, that's the fuel coming from the fuel tank. The fuel tank is located here, that's the fuel, pam, the fuel pass through the fuel transfer pump, enter into the fuel injection pump, and enter into the injectors. Okay, the first heat exchanger to reduce the temperature of the fuel. In the previous example, we don't use heat exchanger for fuel. But in this engine, normally they have a heat exchanger for fuel. Okay, that's the number one. Okay, the salt water continue, and enter in the other one for the engine oil, the motor oil. This is the oil filter. Look, and the oil pass to the serpentine and continue and return. And the salt water continue. Okay, this is the number 2. The salt water continue in other heat exchanger. For the transmission oil. Oh, nice, for the transmission oil. And the salt water, this is the number 3. And the salt water continue, and enter in other one to reduce the temperature. This is the turbo. This is the hot side, and this is the cold side. Oh, nice. This is the air filter. Look, the air is compressed, high pressure. Enter here, and the temperature is reduced before the air enter into the intake manifold. This is the intercooler, number 4. And the salt water continue. The salt water continue. Enter here into the last heat exchanger for coolant. This is the reservoir of the coolant, the radiator cap. The salt water pass, the green, and the coolant. Look at the coolant. The coolant is circulating here. That's the coolant pump. That's the thermostat housing. If the thermostat housing is open, the coolant enter and circulate over there, and return into the block. Okay, the salt water goes out, enter into the elbow of the exhaust, and bye-bye exhaust and water. Okay, this is the number 4, and this is the number 5. Wow, wonderful. This is the path of the salt water and this is the typical amount of heat exchanger. Probably in other engines they have another heat exchanger for the hydraulic oil of the power steering fluid and the autopilot. But in this particular case, we have five heat exchangers, and all of those heat exchangers are using salt water to reduce the temperature of each individual fluid in each case. Okay, I hope you like that picture. And this is other good picture about what happened internally in the heat exchanger. But before I explain that picture, I want to show to yours the same video related with the internally the heat exchanger and how to disassemble the heat exchanger. Look, this is the salt water enter over there, and the salt water continue. This heat exchanger is for one fluid, the input of the fluid and the output of the fluid. We are going to disassemble this heat exchanger in order to understand what happened internally inside of the heat exchanger. Okay, we are going to remove the caps carefully. Look, in each cap, you can remove the caps. In each cap you have the anodes of zinc, the pencil zincs, like the pencil zinc that you have on the screen right now. Those are the sacrificial anodes. In each end you have one pencil zinc, like the zinc that you have on the screen right now. Okay, I am going to disassemble. I am going to remove the caps. Of this heat exchanger in order to verify what happened internally on the heat exchanger. This is the zinc. In this moment the zinc is completely eroded. This is the function of the zinc, is protect the metal of the heat exchanger. This zinc should be replaced because it's completely eroded. Alright, this is the function of the zinc. And in order to keep the seal, an O-ring is located here. This is the O-ring, and the O-ring sit on the cylinder. Okay, we are going to remove the cylinder. Okay, my friends, look, the salt water entered over there. Look, this is pieces of zinc. This is zinc, and the salt water passed through the other side. And the coolant circulate here. The coolant circulate. Look, the coolant enter over there, circulate here with those divisions. The coolant never touch the salt water because the salt water passed through the pipes, and the coolant surrounded the pipes, input and output, or input and output. This is internally the element of the heat exchanger. This is the element of the heat exchanger. Salt water on the pipes, through the pipes, and coolant on the serpentine. This is a typical heat exchanger used for different purposes. This is the housing. Look at the housing. The housing is in aluminum. That's the input, and here is the output, or vice versa. With two caps. If I remove the other cap, I have a perfect cylinder. The material is copper nickel 9010. This is a famous alloy, copper nickel 9010. The material of those pipes is copper nickel. It's an alloy with high content of nickel, and the welding in between those plates and the pipes is with silver and brass. For that reason, when we analyze in the future the oil sample or the coolant sample, if we found too much amount of nickel, probably is because the heat exchanger is broken, or too much amount of silver is because the soldering is degraded, or too much amount of copper, exactly the same. Alright, it's a copper nickel alloy, a special alloy, marine grade, and both O-rings in each side. Those O-rings are special O-rings according with the coolant or according with the fluid used in the heat exchanger. Okay guys, and right now I can explain this picture. Yeah, this is the heat exchanger internally. Okay, let me check the heat exchanger, how the heat exchanger works. Look, this is the salt water. This is the strainer for salt water. Of course, this is the valve, and this is the raw water pump. The raw water pump with the impeller, flexible impeller. That's the difference. What is the main difference between the raw water pump and the coolant pump? The raw water pump, the impeller is flexible. Yeah. The raw water pump should be located below the water line. The coolant pump is bolted on the block of the engine. Not necessary should be installed below the water line. It's bolted on the block, and the function is circulate the coolant. Correct? The coolant pump or fresh water pump or circulating pump is used to circulate the coolant, and the raw water pump is used to circulate salt water. That's it. Okay, the salt water continue over there, enter into the heat exchanger, into the pipes of the heat exchanger, you remember, and continue and goes out through the exhaust pipe. Okay, and let me check the flow of the coolant. Look at the coolant. The coolant enter into the reservoir. Normally you added coolant in your car, in your boat, into the reservoir, into the plastic container, the reservoir. Okay, after that, the reservoir enter the coolant into the expansion tank. The expansion tank is the metallic part over the pipes, like the picture that you have on the screen. Okay, and this is full of coolant, and now the coolant circulate here, and the coolant continue over there. The coolant continue over there. This is the coolant pump. Okay, the coolant pump send the coolant with high pressure, and if the thermostat is open, the coolant continue and enter into the block and the head and circulate and once again return. You like it? This is the explanation about the how the expansion tank and the heat exchangers are integrated together. For that reason, in the majority of the boats, the expansion tank and the heat exchangers are integrated together, exactly like the video that I am going to show to you right now. Check the exhaust manifold and verify where this is the exhaust manifold. This is the heat exchanger. Look, that's the through hole. The salt water enter, pass through the heat exchanger. The salt water enter into the exhaust pipe. In this point, the exhaust gases are mixed with the salt water. This is the point where the gases and the salt water are mixed together. For that reason, this line is the critical point. If this line is below the water line, I need anti-siphon. If this line is over the water line 12 inches, I don't need anti-siphon. If the distance is less than 12 inches, probably you need anti-siphon. Where should be located the anti-siphon? The anti-siphon should be located here. I remove this, I twisted that one like this, and now I pass a hose from this point, goes up into the anti-siphon and return. That's clear? I move it this output like this, I switch like this, and now I pass a hose with the anti-siphon on top in order to avoid ingress of salt water. This is the critical point. It's the point on the exhaust pipe where the salt water is mixed with the gases. Why that point is critical? Because here in the back, if you check in the back, let me show other heat exchanger in the back. Look, here in the back, you have the exhaust manifold. This is the exhaust manifold. It's because here I have the head of the engine, and I have the exhaust valve here, and exhaust valve here. What happens if the exhaust valves are improperly calibrated? What happens if one of the exhaust valves stay open during the intake? You remember what happened during the intake stroke? During the intake stroke, only the intake valve open and the exhaust valve should be closed. When the piston is going down, the air enters. What happens if the
exhaust valve is a little open because it's improperly calibrated. When the piston is going down, suction water because you have salt water here and gases over there. For that reason, the majority of the diesel generators, they need to calibrate the exhaust valve each 250 hours.
Okay, my friends, I hope you enjoy this episode. I hope that you have a clear the function of the heat exchanger, what is the meaning of the expansion tank, what is the meaning of the expansion tank, and what is the function of the reservoir. Let me explain something, okay? This is the heat exchanger. Those are the sinks located in each cap of the heat exchanger. Remember, the function of the sinks is protect the metal of the heat exchanger. Where are located the sinks normally? Where the salt water is passing. If you have circulation of salt water in any part of that path, you install a pencil sink. Yeah, in order to that the free oxygen on the salt water attack those pieces of zinc, and the free oxygen on the salt water never attack the metal of the heat exchangers. That's the function. For that reason, you need periodically, depending of the service manual of the engine, disassembly the heat exchanger and replace the pencil sinks. The pencil sinks, the function is try to capture up the oxygen. The zinc is eroded, but protect the copper nickel expensive alloy. Okay, let me explain quickly. The reservoir tank should be located a little over the expansion tank. The expansion tank is this one, the metallic, and the radiator cap is located here. Okay, and the coolant enter over there. The coolant enter over there, and the coolant enter over there, goes here, circulate through the pump to the block and the head, return into the coolant pump, into the circulation coolant pump, and the coolant, if the thermostat is open, the coolant continue and enter, circulate through the, and return, and once again, and once again. This is the path of the coolant internally, and this is the function of the circulating pump or coolant pump, and this is the function of the thermostat. The thermostat, ABYC question, what is the function of the thermostat? Control the flow of the coolant internally in the engine. ABYC question. Control the flow of the coolant. I hope you enjoy this video. Thank you.